This is a tutorial for Directional Lab of Geotechnical Engineering course CE 382. The purpose of this experiment is to admire the performance of coarse-grained soil under shear. To test this, you'd be using this shear box apparatus. Let's begin. Step 1. Preparing the shear testing box. Contain a mass of the soil in a container and record the mass of the soil. In our case, we'd be using the sand. Assemble the two halves of shear testing box by lightening the facts and tightening the screws. Fill the testing box with soil like this. Fill the most of the box away, leaving a space of half a centimeter above. Gently compact the soil using a hammer. Use this flattening tool to flatten the surface of the soil. This tool also shows that if the level of the soil is appropriate. If there is too much soil, remove some like this. If there is less, then add more. Place the metal plate with ridges on the surface of the soil. Make sure the ridges are perpendicular in the direction of the loading. Loading will be applied on the direction of the large hooks of the testing box. Place the top cap on the top of this. Also, place the small metal ball which hold up the vertical load jig. Step 2. Preparing the shear testing apparatus. After you're done with preparing the shear box, use the two handles of the shear box to place on the shear test apparatus like this. Remove the screws of the two halves which is holding the testing box together. Now, top half of the shear testing box is free to move around. Finalize the setup by adjusting this screw. Step 3. Running the test at each load level. We would be using 3 loads, 4 kilograms, 8 kilograms, and 16 kilograms. Apply each load at the bottom of the loading jigs. Zero the instruments and start the test. Make sure all 3 gauges are connected. Once the horizontal load peaks and then drops off, then stop the test. Repeat this process for 8 and 16 kilograms as well. Store the data and start the upcoming calculations. Step 4. Calculating apparent cohesion and friction angle. For each of your test, horizontal load should climb to a maximum limit and then taper downward. The maximum load should increase with an increase in confining pressure. The vertical displacement of your test should look something like this. Determine the maximum load on each level of confining pressure. Plot the horizontal load in y-axis with 3 confining pressures. Find the line of best fit of these 3 points. The apparent angle of shear resistance should be the angle of this line. The apparent cohesion of the soil is the y-intercept of this line. Calculate both. Now that we have found the both shear strength parameters, this concludes the direct shear test lab.